jet propulsion cycle. This is the last bit of this module 2, that is a jet propulsion. Okay, in the jet propulsion cycle, the gas turbine engines are widely used to power aircrafts because they are light and compact and have high power to weight ratio. Aircraft gas turbine operates on open cycle called as the jet propulsion cycle. Jet propulsion cycle. Okay, here air standard jet propulsion cycle. That jet propulsion cycle, it will be consisting of open cycle gas turbine. Open cycle gas turbine, it will be consisting of compressor, combustion chamber, and turbine. Okay, here the expanded amount of gas which will be living into the atmosphere in the open cycle gas turbine. But here the expansion of the gas, exhaust gas, which will be expanded through a nozzle. Okay, this is a major component which will be existing in the jet propulsion cycle. Okay, here one more thing is there here. Before air which will be admitted during the suction stroke, okay, directly during the compressor in the simple gas turbine cycle. But here what happens in the jet propulsion cycle, before the air which will be admitted in the compressor, will be having a one more component will be existing, that is you can call as a diffuser. Air which will be enter into the diffuser from the atmosphere. Here what is the function of the diffuser is, it will be compressed the air, compress the air from, okay, then it will be compressed air, okay, high pressure air, once again it will be passed to the compressor, then a highly compressed air which will be passed to the combustion chamber. Here the fuel is admitted to the combustion chamber. Okay, then afterwards enormous amount of heat energy will be liberated. That heat energy will pass it to the turbine. In the open cycle what happens, it living into the atmosphere, but here the expanded amount of gas which will be air which will be passed through a nozzle. Here in the high pressure, high velocity, the nozzle, the expansion of air will be taken, the gas which will be taken place through a nozzle, which will be gives the thrust force to the aircraft. This is the mechanism which will be existing for the jet propulsion cycle. Okay, and the nozzle, the function of the nozzle is it should give a thrust force to the aircraft, which will be aircraft which will be lift the air from the earth. Okay, like that, that aircraft will be flying through that in the air. Okay, this is the one of the mechanisms, simple mechanism which will be existing in the air standard jet propulsion cycle. Okay, then this is what the thrust force. Force is equal to ma into Vs minus V1. Okay, that is a force. Okay, As is equal from the, that is what, ma, mass of air, initial velocity and final velocity will be existing here. Okay, then it will be having another one engine, that is you can get turbojet engine. That turbojet engine which will be consisting of compressor, combustion chamber and turbine. Then turbine will be once again connected to a nozzle. Okay, here that air which will be admitted to the compressor, before the air which will be passing through a diffuser. In the diffuser, the velocity of the air which will be slowed down, the pressure which will be increases, that high pressured air which will be coming into the compressor, that compressed air once again passed to the combustion chamber, enormous amount of heat energy will be liberated, then it will be passed to the turbine, then the turbine, the expansion will be taken place here. That expanded gas, which will be once again passed to a nozzle, through a nozzle, high velocity exhaust gas leaving from the nozzle to the atmosphere. It will be gives a thrust force to the jet. Okay, in this way, that aircraft will lift to the air. Okay, here once again the turbine and compressor which will be mounted on the same shaft. Okay, this jet propulsion side, this turbojet engines are, it will be in the aircraft engine we are using. Okay, in the traveling of 800 to 889 kilometers per hour, in such velocity of aircrafts, the turbojet engines are used. Okay, this is the, and also this is one of the drawback is high cost, being very noisy are the major problems of turbojet engines. Okay, now another one is turbo propeller. Propeller is mounted, this is you can call as a propeller. This propeller, it should be mounted on the in front of the diffuser, in front mounted and in front of the diffuser. What is the function of this propeller? Propeller is used to produce a thrust by changing a momentum of the fluid around it. Due to that one, the aircraft that is flying, it should be taken place and it will give the direction to the aircraft. Okay, then this propeller is mounted and mounted to the diffuser. Then what is the function of the diffuser? The kinetic energy of the air, which will be converted into potential energy. That means what I am telling is the velocity of the air which will be reduces, the pressure of air which will be increases, that high pressured air once again passed to the compressor, which will be once again passed to the compressor, which will be compression will be taken place. Highly compressed air once again passed to the combustion chamber. Then the expansion of it will be taken place in the turbine. Then the turbine and compressor is mounted on the same shaft. Then that expanded gas, it will pass through a nozzle, high velocity exhaust gas through a nozzle, it will be beaming into the atmosphere. This will be gives a thrust force to the aircraft. This is, you can call it a turbo propeller. This is a conventional air in the aircraft application. We are using this turbo propellers. Okay, turbo propeller. In the turbo propellers, we are using this type of engines in the 480 to 640 kilometer per hour. Okay, slow speed aircraft application, we are using this type of turbo propeller. That is, you can call a conventional aircraft. The simple aircraft applications, we are using this turbo propeller engines. Okay, this is the one thing. Then another one is what? Ramjet engine. This is very, very important thing. Okay, ramjet engines are usually capacity to fly at supersonic speeds. In such type of aircraft applications, we are using this ramjet engine. That ramjet engine, it will be consisting of diffuser, combustion chamber and nozzle. Okay, before going to this combustion chamber, we will be having a diffuser is there. That diffuser, it will be the converts the air that it will be entering into the supersonic speed to the subsonic velocity, supersonic to the subsonic velocity, it will be converted in the air velocity, it will be converted supersonic to the subsonic. Then high pressured air once again passes to the combustion chamber. In the combustion chamber, what happens? The combustion will be taken place, high velocity, high thermal energy which will be releases. That thermal energy of gas which will be leaving into the nozzle through a nozzle, exhaust gas which will be leaving from the nozzle. This nozzle, through a nozzle, high velocity gas which will be leaving from the nozzle, it will be giving a thrust force to the aircraft. Okay, this type of ramjet engine we are used in the high velocity aircraft application. We are using this ramjet engine. This ramjet engine consisting of diffuser, combustion chamber and nozzle. Okay, this function of the nozzle is the air entering the ramjet plant with a supersonic speed. It will be entering through a diffuser, then it will be reduced the supersonic speed. Air it will be converted into subsonic. Okay, then increasing the pressure of the air. Okay, then afterwards it will pass it to the combustion chamber. Enormous amount of heat energy to be releases through a combustion chamber. Then exhaust gas which will be leaving into the atmosphere through a nozzle. Nozzle, when it will be through a nozzle, it will be entering into the exhaust gas, which will be give a thrust force to the aircraft. This type of engine we are using a high velocity application of aircraft application. We are using ramjet engines. Okay, then another one is rocket propulsion. Okay, this is another one important topic, rocket propulsion. Okay, this rocket propulsion single stage, that is a rocket propulsion, liquid propellant. It will be consisting of fuel tank, hydrogen tank and oxidizer tank and pump. These pumps are driven by steam turbine. Then this steam turbine, okay, that it will be runs this pump. Then it will be passed to the combustion chamber. Then through a combustion chamber, high velocity exhaust gas will be through a nozzle. Okay, this is the components are existing in the rocket propulsion. Rocket propulsion consisting of fuel tank, hydrogen tank and oxidizer tank and pumps. These pumps are driven by steam turbine. Okay, then afterwards that steam, that oxygen, it will be supplied to a combustion chamber through a Pumps are driven by steam turbine. Then that combustion will be taken place in the combustion chamber. Then enormous amount of heat energy to be liberated. That the gas, that exhaust gas, leaving through a nozzle. Okay, high velocity exhaust through a nozzle, which will gives a lift force to the rocket, yeah, which traveling in a high velocity speed. Okay, this is the functioning of the rocket propulsion. Okay, here that how the steam turbine will be existing, the steam formation will be taken place with a two chemical elements which will be existing in the uh, rocket propulsion. Those chemical elements are concentrated hydrogen peroxide with potassium permanganate, which will be mixed in the fuel tank. Then it will be produces a steam. This steam which will be passed to the combustion turbines, which will be runs this pump. These pumps are supplied to the oxygen and fuel to the combustion chamber. Here the combustion will be taken place in the combustion chamber. Enormous amount of heat energy to be liberated. That the exhaust gas are leaving through a nozzle. How much amount of high velocity leaving from the nozzle, which will give a thrust to the force to the rocket move in a opposite direction. It will be moving in a opposite direction. The direction of this rocket will be flowing in opposite direction of exhaust gas leaving from a nozzle. This is the functioning of rocket propulsion. This is all about the theory aspects of this module. Module 2, that is what gas turbine cycle. The first portion is gas turbine cycle. Second portion is jet propulsion. Okay, this is the last bit of this jet propulsion. Okay, this is all about this module 2. Now I will stop it here. All of you can refer my notes. Everything is available in my notes. Be concentrated and study well. Okay, thank you. I will stop it here.